Yes, single-phase transformers exist that can boost single-phase power to three-phase, typically for machinery like motors, pumps, and compressors. These transformers employ a technique called phase shifting to convert single-phase to three-phase power. The process involves taking the single-phase input and using a combination of capacitors and inductors to generate three output phases that are 120 degrees out of phase with each other. This arrangement effectively creates a three-phase power supply suitable for operating three-phase machinery. It is important to note that certain types of machinery, especially variable frequency drives, often called VFD, are sensitive to the quality of the three-phase power supply. Therefore, it is crucial to ensure that the single to three-phase converter aligns with the specific requirements of the machinery being powered. To determine if a single to three-phase transformer suits a specific application, consulting with a qualified electrician is recommended. An electrician can assess the specific needs of the situation and offer guidance on the most suitable solution. The conversion from single-phase to three-phase power involves understanding the principles of phase shifting and the components used in the process. Capacitors and inductors play vital roles in creating the necessary phase difference between the three output phases. The selection of appropriate components and the design of the transformer are crucial for ensuring a stable and reliable three-phase power supply. When considering a single to three-phase transformer, several factors must be taken into account. Firstly, the power requirements of the machinery need to be assessed to determine the appropriate size and capacity of the transformer. Secondly, the input voltage and frequency of the single-phase power supply should match the transformer specifications. Thirdly, the output voltage and frequency of the three-phase power supply must align with the requirements of the machinery being powered. Furthermore, the quality of the three-phase power supply is crucial for the proper operation of sensitive equipment, such as VFD. Factors such as voltage balance, harmonic distortion, and transient voltage surges can impact the performance and longevity of the machinery. Therefore, it is essential to select a transformer that provides a stable and clean three-phase power supply. In addition to selecting the right transformer, proper installation and maintenance are also important. The transformer should be installed in a well-ventilated area to prevent overheating. Regular inspections should be conducted to identify any signs of wear or damage. Furthermore, the transformer should be protected from moisture, dust, and other environmental factors that can affect its performance. There are several types of single to three-phase converters available in the market. One common type is the rotary phase converter, which uses a rotating electrical machine to generate the three-phase power. Another type is the static phase converter, which uses electronic components to create the three-phase power. Each type has its advantages and disadvantages in terms of cost, efficiency, and performance. Rotary phase converters typically offer better performance and can handle larger loads, but they are more expensive and require more maintenance. Static phase converters are more compact and less expensive, but they may not be suitable for all types of machinery. The choice of converter depends on the specific requirements of the application. When selecting a single to three-phase transformer, it is important to consider the efficiency of the transformer. The efficiency of a transformer is the ratio of the output power to the input power. A higher efficiency means that the transformer will waste less energy in the form of heat. Energy-efficient transformers can save money on electricity bills and reduce the environmental impact of the electrical system. Transformers typically have efficiency ratings ranging from 95% to 99%. The efficiency of a transformer depends on its design, materials, and operating conditions. Larger transformers tend to be more efficient than smaller transformers. Transformers that are operated at their rated capacity also tend to be more efficient than transformers that are operated at light loads. It is also important to consider the impedance of the transformer. The impedance of a transformer is a measure of its resistance to the flow of alternating current. A lower impedance means that the transformer will be able to deliver more power to the load without experiencing significant voltage drops. The impedance of a transformer is typically expressed as a percentage of its rated voltage. Transformers typically have impedance ratings ranging from 2% to 10%. The impedance of a transformer depends on its design and materials. Transformers with lower impedances tend to be more expensive than transformers with higher impedances. Another important factor to consider is the insulation of the transformer. The insulation of a transformer is the material that prevents electrical current from flowing between the windings. The insulation must be strong enough to withstand the voltage stresses that occur during operation. The insulation of a transformer is typically made of paper, oil, or epoxy. The type of insulation used depends on the voltage rating of the transformer. Transformers with higher voltage ratings require stronger insulation. In addition to these factors, it is also important to consider the safety features of the transformer. Transformers should be equipped with safety features such as overcurrent protection, overvoltage protection, and temperature protection. Overcurrent protection protects the transformer from damage caused by excessive current flow. Overvoltage protection protects the transformer from damage caused by excessive voltage. Temperature protection protects the transformer from damage caused by overheating. These safety features help to ensure the safe and reliable operation of the transformer. When installing a single to three-phase transformer, it is important to follow all applicable electrical codes and safety regulations. The transformer should be installed by a qualified electrician who is familiar with the installation requirements. The transformer should be properly grounded to prevent electrical shock hazards. The transformer should also be protected from physical damage. Furthermore, the transformer should be inspected regularly to ensure that it is operating properly. Regular maintenance can help to extend the life of the transformer and prevent costly repairs. Maintenance tasks may include cleaning the transformer, tightening connections, and inspecting the insulation. In conclusion, single-phase to three-phase transformers are a viable solution for powering three-phase machinery in locations with only single-phase power. However, it is important to select the right transformer for the application and to ensure that it is properly installed and maintained. Consulting with a qualified electrician is recommended to ensure that the transformer meets the specific requirements of the machinery and the electrical system. Understanding the principles of phase shifting, the components used in the process, and the factors that affect the performance and safety of the transformer is crucial for making informed decisions. By carefully considering these factors, it is possible to achieve a reliable and efficient three-phase power supply for a variety of applications. It is also beneficial to understand the different types of transformer connections. The most common types of transformer connections are delta and Y. Delta connections are typically used for three-phase power distribution, while Y connections are typically used for single-phase power distribution. The type of connection used depends on the voltage and current requirements of the application. Delta connections provide a higher voltage and lower current, while Y connections provide a lower voltage and higher current. When selecting a transformer, it is important to choose the correct connection type for the application. The transformer's kV amp rating is also a crucial factor to consider. The kVA rating represents the apparent power that the transformer can handle. It is calculated by multiplying the voltage and current ratings of the transformer. The kVA rating should be greater than or equal to the total power requirements of the loads connected to the transformer. If the kVA rating is too low, the transformer may overheat and fail. It is always better to select a transformer with a slightly higher kVA rating than is required to provide a margin of safety. Another aspect is the transformer's voltage regulation. Voltage regulation is a measure of how much the output voltage of the transformer changes as the load changes. A transformer with good voltage regulation will maintain a relatively constant output voltage even when the load varies significantly. Poor voltage regulation can cause problems with sensitive equipment that requires a stable voltage supply. Voltage regulation is typically expressed as a percentage. Transformers with low voltage regulation percentages are generally more desirable. Furthermore, understanding the concept of transformer taps is important. Taps are connections on the transformer winding that allow the output voltage to be adjusted. Taps are useful for compensating for voltage drops in the electrical system. They can also be used to adjust the output voltage to match the requirements of the load. Transformers may have multiple taps that allow for a wide range of voltage adjustments. The National Electrical Code, often referred to as NEC, provides guidelines for the safe installation and operation of transformers. Article 450 of the NEC covers the requirements for transformers, including overcurrent protection, grounding, and ventilation. It is important to comply with all applicable NEC requirements when installing and operating a transformer. Failure to comply with these requirements can result in electrical hazards and equipment damage. Understanding the different types of transformer cooling methods is also crucial. Transformers generate heat during operation due to losses in the core and windings. This heat must be dissipated to prevent the transformer from overheating. Transformers can be cooled by various methods, including air cooling, oil cooling, and water cooling. Air-cooled transformers are typically used for smaller transformers, while oil-cooled and water-cooled transformers are used for larger transformers. The type of cooling method used depends on the size and power rating of the transformer. Furthermore, understanding the concept of transformer inrush current is beneficial. Inrush current is the high current that flows into a transformer when it is first energized. The inrush current can be several times higher than the normal operating current. This high current can cause problems with circuit breakers and other protective devices. It is important to select circuit breakers that are capable of handling the inrush current of the transformer. Soft start devices can also be used to limit the inrush current. Also, harmonic distortion in transformers is a concern. Harmonic distortion is the presence of unwanted frequencies in the electrical system. Harmonics can be generated by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause problems with transformers, including overheating, reduced efficiency, and increased noise. It is important to mitigate harmonics in the electrical system to protect transformers and other equipment. Harmonic filters can be used to reduce harmonic distortion. Transformer noise is another factor to consider. Transformers can generate noise due to the vibration of the core and winding. The noise level can vary depending on the size and design of the transformer. In some applications, it may be necessary to use noise reduction techniques to minimize the noise level. Noise barriers and vibration isolation mats can be used to reduce transformer noise. To summarize, when working with single-phase to three-phase transformers, understanding concepts such as phase shifting, kVA ratings, voltage regulation, transformer taps, NEC requirements, cooling methods, inrush current, harmonic distortion, and transformer noise is essential for optimal performance and safety. Remember to always consult with a qualified electrician for any electrical work.